Hi everyone, so let's talk about the count square submatrix with all 1. So you're given an unbiased matrix. So you have to return how many square submatrix have all 1s. So this question is actually really standard. So let's just do this. So if the cell is actually 1, you have to add. So there are 10 of the 1, right? And for 2 by 2, right? You have 4 of them, right? This is 1, this is another one, this is another one, and last one, right? And then for 3 by 3, which is the big one, so this is what 3 by 3, this is 1, so add everything else, it should be 15, right? So how do you actually solve this? So you have to find out your current cell, which is 1, and if the current cell is actually 0, we don't care about it. If the current cell is actually 1, we have to go for our neighbor unless the I equals to 0 and j equals to 0, we don't have to traverse because you cannot create a submatrix based on that. So we will just keep updating our current matrix value. We have to find out the minimum between top left and top left. So imagine this one, the minimum between top 1, left 1, top left is actually 0. So the minimum between these three cells is actually 0. So 0 plus 1, because you have to add your current 1. So this is 1 still. And how about the next one? So for the current cell is 2 2. Sorry, 1 2, right? The neighbor is actually what? 1 1 1, right? So minimum between this is actually 1, and your current cell is also 1, so you have to add 1, so which is 2. So you update to 2 right over here, and then for the next one, you have to check your neighbor. The minimum between these three is 1, so 1 plus 1 is actually 2 because your current cell is actually 2, right? And then you just keep doing this, and then once you get this, you have to traverse bottom right? Because the minimum between these three is actually 2, 2 plus 1 and 3. So you just have to add everything up. So why is this 3 and every other else is 2? So let me draw a better diagram. So this is 1 1 1, right? So I'm talking about I'm going to talk about the bottom right first, which is 3, right? So your current 1 is 3. The 2 by 2 is actually it's actually 1. I mean, you actually count as 1 as well, right? And then 3 by 3 also count as 1, so this value is actually 3. So just add 3, and another one, and this is going to be 2, right? So this is 1, and this is also another 1, right? And this one doesn't count because you already come for the bottom right. So you only have 2, right? And this is a solution, so let me code it and you'll be able to follow along, right? So you need to return value for result. Return results. And then I also need a n equal to metric length n equal to metric at 0 length, and then traverse the entire metric. And then let me see if metric at I and j is actually greater than 0, right? And also I is greater than 0, and also j is also greater than 0. You need to do something else, right? So what happens if they are not if they are actually equal to 0 and I equal to 0 and j equal to 0, you just increment your current cells. I mean just add to the result. So if there is 0, then just add 0. If there's 1, just increment, right? And then you need to keep updating your current cell based on starting from 1 to 1 to bottom right? So metric ij equal to mean. And I'm going to say metric, this is going to be what? Top left, I minus 1, j minus 1, right? And comma, I'm going to say mean again, metric at what? I minus 1, j comma I j minus 1. And everything else you have to plus 1 because you need to add current value, which is 1. And then let me run. And yeah, here we go. So let's talk about time and space. This is going to be a space constant. This is going to be time, order of n plus n times m, right, for the time complexity. And this is the solution, and I will see you next time. Bye.